Okay, this is a pretty challenging problem here. So, a company estimates that it can sell 3,000 units each month of its product if it prices each unit at $90. However, the monthly number of sales will increase by 20 units for each 20-cent decrease in price. Then we're given the fixed cost and the cost of making each unit. We want to find the level of production that will maximize the company's profit. So we need to start by defining some variables. And the two variables that will make this easy is to define it using R and N. So I'm going to let lowercase r right here be the number of 20-cent reductions in price, right? Because that's what we're considering. So we're trying to figure out how to price the items and how many to produce, both. And N is the number that we're going to produce and sell. We're assuming that we sell everything we produce. Okay, so we're trying to find both of those things. We should produce this many units, so that would be N, at a price of, we'll call that price P, and then lowercase p, and then we'll find the profit. Okay, so generally, profit we write as capital P, revenue minus the cost. Okay, generally. So what we need to find is revenue and cost in terms of either lowercase r or n, either way, and then figure out profit, differentiate it, find what has a max, and then we'll go from there. So let's start with finding revenue, actually. Let's go here with R. So the revenue, that's the money that we're bringing in. So currently, let's just say currently we're selling 3,000 units at a price of $90 each. So the revenue is the money brought in by those sales, which is their product, 3,000 times 90. But we're considering changing it. Okay, so let's just write it out what it generally means. Generally, revenue means it's the number of items sold times the price that they're sold at. We're going to find each of those with these in terms of R and N. So the number of items that we sell, currently we're selling 3,000 is the idea. But the sales will increase by 20 units for each 20-cent decrease in price. So if we have R, lowercase r decreases in price, for each R, sales increase by 20. So we're going to say plus 20R. That's the number of items that we're going to sell. The price that they're being sold at, we're starting at 90, and then we are decreasing the price by 20 cents R times, so minus 0.2R. Okay, so that gives us revenue, capital R revenue, in terms of lowercase r, which we should definitely go ahead and expand and simplify. So formulating that out, 3,000 times 90 is 270,000. Then 3,000 times negative 0.2, negative 600R. That's the outside term. And the inside term, 20 times 90 is 1,800R. And then the last term is 20R times 0.2R is going to be 4, negative 4R squared. So combining those two middle terms gives 1,800 minus 600 is 1,200. Okay, so that is capital R revenue. Cost, let's look at cost next. So capital C, that's the cost to you, the manufacturer. So how much is it costing you to produce these units? Well, you have fixed cost of $4.50. That's no matter what. So it's $4.50 plus $4.40 for each item that you sell. So 4.4 times N, the number of items that you are producing. Problem here is that now we have two variables. We have lowercase n and lowercase r. We need to get them the same. So let's figure out how R and N are related. So if N is the number of units produced and sold, then N, let's put this over here, N, okay, currently we are selling, actually I already did this right here, that is N, because currently we're selling 3,000, right, and then we sell 20 more for each reduction in price. So it is 3,000 plus 20 R. Now you have two options here. You could solve this equation for R and plug it in here and here. I think that would be the harder way to do it. So I'm going to, because it's already solved for N, I'm going to plug it in for N right there in the cost function to get 450 plus 4.4 times 3,000 plus 20R, and simplifying that, 3,000 plus 4.4, or times 4.4 is 13,200. 20 times 4.4 is 88. So then this comes to 450 plus 200 is going to be 650 plus 88 R. So that is my cost function, capital C. So now we are ready to find profit, which is the revenue minus the cost. So, profit here. The profit is revenue, which is 27, and this is over here, 270,000 plus 1,200 R minus 4R squared minus the cost, 13,650 plus 88 R. Simplify this. So 270,000 minus 13,650 is 256,350. We've got 1,200 R minus 88 R is 1112. So this is going to be plus 1112 R, and then we have the minus R, 4R squared. Alright, so there's my profit function in terms of lowercase r. That's fairly easy to differentiate, but I'm going to keep going. It's a complex problem. So P prime of R is that derivative is 0. This derivative is 1,112. And then we have minus 8R. So we want to find where P has a max. So obviously it's a parabola. It opens down because this has a negative coefficient in front of the r squared term. So we'll just set it equal to 0. So where does 1112 equal 8R? 1112 divided by 8 is 139. So this is saying we should have 139 reductions in price by 20%, is what that's saying. So we should reduce the price by 20 cents 139 times. So what is 139 times 20 cents? Let's see what the total reduction in price should be. $27.80. 80 cents. So we should reduce the price by $27.80, which would bring the price down to, let's see, price is currently $90 for each unit. So 90 minus 27.50 would be $62.20. Okay, so that's the price we should sell them at. Now we need to figure out how many items that we're actually going to be selling, which brings us back up here to N. Okay, brings us back to N. So N is going to be 3,000 plus 20 times R, which we found to be 139. And that'll tell you the number of items that we should sell. I want to go ahead and find it. 20 times 139 plus 3,000 is 5,780. 5,780 items is what you should produce, and hopefully you'll sell everything that you produce. So it's a complex problem. If you have any more questions about it, please let me know.